Okay, in this video we're going to talk about Unit 2 Objectives 6 and 7, the derivatives of e and natural log. So much like the trig rules, the derivatives of e and natural log are almost always going to use the chain rule. And again, like the trig rules, I'm going to go ahead and define the derivatives of e and natural log in terms of the chain rule, so we don't really have to think about it. So we're going to let u be some function of x, so something like x squared or x to the fourth plus 7 or whatever. So the derivative of e to the u is going to be u prime e to the u. So the derivative of e is just e. And then the derivative of natural log of u is going to be u prime over u. So again, the u prime that you see in your numerator here and multiplied by your e over here, that's taking the chain rule into account already. We don't have to worry about finding the chain rule. It's going to be there in our definition already. So let's look at a couple of problems. So this first one, find y prime if y equals e to the x plus x squared. So if we're thinking about this, u is going to be x plus x squared. So y prime, we know from the rule we just said, is u prime e to the u. So if we think about this function here, u prime, derivative of x is 1, derivative of x squared is 2x. So y prime is going to be 1 plus 2x times e to the x plus x squared power. This is one of those ones where you have to be careful, make sure you have parentheses. Or else the AP graders, if this were a free response question, if you leave the parentheses off and write it like this, the graders are going to assume you're only multiplying the 2x by the e, not everything by the e. So make sure we have our parentheses when we're dealing with these derivatives. So that's a pretty basic e derivative. Let's look at a natural log, a pretty basic natural log. Not basic, sorry. This is pretty involved here. U is going to be sine of x squared plus 3x. So if we're looking at this, f prime of x has got to be u prime over u. If we look at our u here, we actually have chain rule again, but it's a trig rule, so we should kind of have the chain rule inside of what we already know. So the derivative of sine is u prime times cosine of u. So this u is going to be the x squared plus 3x. So we have 2x plus 3 times the cosine of x squared plus 3x. So that's going to be our u prime for our big function, our function f. So for finding f prime, we take u prime, so 2x plus 3 times cosine of x squared plus 3x, and we put that over u, not the natural log of u, just u, so that's going to be over sine of x squared plus 3x. And if you don't like looking at this as a fraction, we can take advantage of the fact that the angles of which we are taking our cosine and sine are the same. Cosine divided by sine is cotangent, so if you wanted to rewrite this problem, or this answer rather, as 2x plus 3, quantity 2x plus 3 times cotangent of x squared plus 3, you can do that as well. That's something AP is probably going to do, is simplify it that way, so make sure you remember your basic trig identities. So now we're going to get into something that AP loves to do. They like to combine e's and natural logs. So in this problem we're starting with e to the power of 3 natural log of x. Now if you wanted to, you could say u is 3 natural log of x, so u prime would be the derivative inside the log, so the derivative of x is 1, over what's inside the log, x, and then this 3 just kind of gets multiplied, so that would really be 3 over x. So that's u prime, so we could say y prime equals 3 over x e to the 3 natural log of x. And we could leave our answer as that, but we can do something to make their lives a little bit easier. If we simplify this problem from the very beginning, we can get an answer that's very, very quick, very, very easy, and we'll be moving on. Because if this were a free or a multiple choice question, this is not how AP is going to look at the answer. So what we actually want to do on this question is take what we started with and use what we know about logs and e's. So we know this 3 outside the log. We can bring this forward and make it the exponent of x. Now that's going to be useful because now I have an e to the power of natural log, and if you remember your trig, the e and the natural log are going to cancel each other out. So we're really looking at y equals x to the third. So we can simplify it that way before we even take a derivative, and now this derivative is very straightforward, 3x squared. So you're probably looking at this one and saying, well, how are we going to get 3x squared out of 3 over x e to the 3 natural log of x? Well, if we do the same thing, take this 3, bring it up there, we're going to get 3 over x e to the natural log of x to the third. Those are going to cancel. We get 3 over x times x to the third. That's going to cancel with one of those, making it a square, giving us 3x squared. So if you want to take it this way and then have to simplify to get 3x squared, you're more than welcome to. But what AP is going to expect you to do, and what I expect you to do, is simplify your problem first, turn it into a polynomial, and then just use your power rule. So that's going to do it for this video. We'll see you in the next one.